Hello students, and welcome again to today's lesson. Today we're going to be checking stationary points, that is from calculus differentiation, okay? And this is a very commonly tested question from each and every series of Knec. So you can get yourself some 8 marks by doing such a question. So we have a question here. My name is Mr. Meshak. Kindly remember to subscribe, share, and also comment. So we have the question: determine the coordinates of the stationary points of the function f, a function of x and y. So you can see it is given in terms of x and y here, and so you're supposed to find the coordinates and also classify them. Okay, now remember, you can see this is a function of 2 variables. So by that by that you just know one thing, that you'll use partial differentiation to do this question. So if the function had one variable, if it was fx without the y, and variables here only x, then you'll use dy dx. But now since we have more than one variable, then we'll have to use partial differentiation. But it is a very simple question, so let's go and see about it. So first of all, we just rewrite our function to be in terms of z. So we let this one to be in terms of z. So then xy plus y squared plus x squared plus 2. So 1, from partial differentiation, you're supposed to get dz and dx. Remember, this one is curl d to show that it is a partial derivative. So we are saying, we always say, when you differentiate partially, all the other variables are treated as constant. Are treated as constant. Only you differentiate with only the variable that you are given. So we are differentiating our function z with respect to x. So if we are differentiating with respect to x, we shall only differentiate the x, but we treat y as a constant. So for example, when you differentiate x, you get what? So when you differentiate x, you'll get 1. So you'll get 1, okay? Then y is also a constant, so you'll be like having 1 times y. So basically you'll have what? You'll have y. We don't have the variable x here, so you don't differentiate. Then you differentiate this function, then plus 2x. When you differentiate that, you get 2x. Then this one is a constant. When you differentiate a constant, you get a 0. Then 2, we also get dz dy. Okay, so again here we now differentiate with respect to y. So if we differentiate with respect to y, differentiate y alone. Differentiating y alone, you get 1. So 1 times x, we just get what? Just get x, because x is a constant. We're not concerned with it. It's treated as a constant. Then we have y here. We'll get what? We'll have 2y. This x squared doesn't have a y, and this one is a constant, so it becomes 0. Then the second step after getting dz dx and dz dy partially, then we replace these values to let them to be equals to 0, so that we can be able to get our stationary points. So this one, or plus 2x equals to 0, and also x plus 2y equals to 0. So we have this and we have this, so we have to solve these 2 equations, and we can solve them simultaneously. But again, you don't need to really solve it, because anytime you shall have 2 simultaneous equations and the right hand side are zeros, your answer of x and y will always be what? Will always be zeros, as long as it is not quadratic. It's not a quadratic equation. As long as they are linear, it means that when you have a number here and when you have a number here, there is no way you can have a different number here for you to get a solution to be 0. There is no way where you can have 2 different numbers here and get your answer to be what? To be equals to 0. Okay, so basically we'll say your value of x and your value of x will be 0, and your value of y will also be what? Your value of y will also be 0. Okay, now so your point therefore will be 0. Your point will be 0, 0. Okay, now so you have your point. Now the second part, you find the nature. We say you classify them. So remember, in partial differentiation, you can only have 3 points. It's a maxima, a minima, or a what? Or a saddle point. So you either identify if it is 3, either of them. So we know we're supposed to use the formula D. So you're supposed to get this change here. So delta will be given by, so change will be given by dz, then you have dx dy, then squared minus dx dz, sorry, squared, then x squared, then you have dz squared, then dx squared, dy squared, sorry. So we have our our dy squared. So we're supposed to get this term, and we're supposed to get this and get this. So now we had already differentiated once, differentiate it again. So d squared z dx squared. So differentiate this with respect to x. There's no x here. Differentiating this one, you get what? You get 2. Then we come to the d squared z dy squared. Then differentiating this one again with respect to y the second time. There's no y here. Differentiating this one, we just get what? We just get 2. Then we're remaining with this. So dz dx dy. So this means that the function that you had differentiated with respect to y the first time, you now differentiated with respect to what? With respect to x. So which function had we differentiated with respect to y? It is this function. So this function, so this is the same as saying d dx of this function here, x plus 2y, right? It is the function you are differentiated with respect to y, then differentiated with respect to what? With respect to x. So when you differentiate this one with respect to x, you get what? You get 1. Now let's replace our values. So we have change there will be given by, so what is our value of dz of dx dy? It will be given by 1. So 1 into bracket squared minus, what is our value here? It's given by 2. Then what is our value here? Is also 2. So we'll have 1 minus 2 times 2 gives you 4, which gives you negative of what? Negative of 3. When you have your value being negative, then we say there's 2 possibilities. You can either have a maximum or a minimum. Are we together? It can be a maximum or a minimum. Therefore, when you have this value being negative, you go back and check this value. Check your value of d squared z dx squared. Was it a positive or a negative? So we say, but our d squared z dx squared is equals to 2, which is greater than, you can say this one is greater than what? Is greater than 0. And if it is greater than 0, then we say this point is, if it is greater than 0, then it becomes a what? It becomes a minimum. So therefore your point 0, 0 is a minimum point. So therefore, this is your solution. So this one gets you 8 marks. So basically what you're saying is we have 4 steps, around 4 steps for you to handle when you're handling stationary points. So 1, you get your dz dx. 2, get your dz dy. Then you solve the 2 equations either simultaneously if they are linear, or if they are not linear, then you just solve them the way you can solve any other equation. Then you get your value. You'll get your value of x and you'll get your value of y. Remember, it is not a must for the values to be only 1. They can be more than 1 value. Then the second point is you're supposed to replace your values by differentiating the second time and replace them in this formula here. So when you get your change here, then you replace in this formula. So you get dz with respect to x and y, then with y, x the second time and y the second time, then you get your 2 values. Then after replacing your value, there are 2 possibilities. You can get your value being greater than 0. Okay, it can be greater than 0 or less than 0. If it is greater than 0, then we say that is a saddle point. That is by default a saddle point. If it is less than 0, then we say we have 2 possibilities. It can either be a maximum or a minimum. But what tells you if it is a maximum or a minimum? You go back and check your what? Your dz squared, d squared z dx squared. If this value here is greater, if this value is greater than 0, then that is a minimum point. If this value is less than 0, then we say that is a maximum point. Now let's check example number 2. So let's check the second example from July 2022 series. Again, remember to subscribe, share, and also comment. Now locate the stationary points at the curve f, a function of x and y given by that function, and determine their nature. So solution. So again, we shall let our fx y to be given in terms of z, which is now this function 3x squared minus this should be y, sorry for that, plus 6xy plus 4. So we are said we get our dz dx. So we differentiate with respect to x. Okay, so we drop the power and reduce the power by 1. So dropping the power, we get what? 6x. This variable does this one does not have an x, so we differentiate this one with respect to x. So this x will become 1, so we remain with 6 and y. So plus 6y. 4 is a constant, you don't differentiate it. Then we come to dz dy, which will give you now this variable does not have a y, so we differentiate this one, which will give us negative 3y squared. Then differentiate this with respect to y. This y goes, we remain with what? We remain with 6x. This one is a constant. Again, it becomes 0 by the end of the day. Now we let this and this to be 0. So now dz dx, we let them to be 0, and also dz dy to be equals to 0. So this function to be equal to 0, this one to be equals to 0. So 6x plus 6y, we let it to be equals to 0, and negative 3y squared plus 6x equals to 0. Now this is a linear function, but this is not a linear function. So by the end of the day, we'll have to find a way of solving the two equations. So here we shall let one of the variable to be the subject of the formula. So we shall use y, so that you can replace this square part here. That will be easier. So let's make y the subject of the formula. So we take x the other side. So we shall have in the equation number 1, we shall have negative 6 of x, then we divide by 6, so that goes, we have y equals to negative of x. Now replacing, we replace the value of y, value of y, which is negative x, in the second equation. So we shall have, so we replace y equals to negative x in 2. So you can say this is equation 2, this was 1. So we replace it here. So we shall have in 2, we shall have negative 3. Now our y is given by negative x, so we shall have negative x, then squared plus 6x, which gives you 0. When you square a negative number, it gives you a positive, but we still have the negative. So we shall have negative, then we shall have x squared plus 6x equals to 0. We can eliminate our negative here. Let's eliminate the negative by multiplying everything by negative. So multiplying by negative all through, this one by negative becomes 3x squared. By negative here we have negative 6x. We don't have a negative of 0, so 0 is just 0. Okay, so let me split this into 2. Now let's come to this side. So we have this. Let's now solve for the value of x. So we shall have, if 3x squared minus 6x equals to 0, we can factor out a common term here, which will be 3x. So we remain with x minus what? Minus 2, which gives you 0. So now it is either, when you have two factors which have been multiplied together and the result is 0, then it's either one of them was 0. So it's either 3x is equals to 0 or x minus 2 equals to 0. So the value of x here will be what? To divide by 3 becomes what? 0 divided by 3 is just 0, or x will give you what? Give you a positive of 2. So we can see here we have two values of x. So therefore, if you have two values of x, then you're going to have two values of y. So when x is 0, now let's come here. Our y will be what? Our y will be, so negative of 0 is just be 0. Then when x equals to 2, what will be a value of y? Replacing 2 here in this value, so we shall have y equals to negative of 2. So therefore, we shall have your stationary points will be the stationary points will be 0, 0. Will be 0, 0, and 2, negative 2. So you can see in this case we have now two values. Now when you're going to be getting the nature, we're going to get the nature of this point and also the nature of this point, because this point and this point are not occurring at the same place in the Cartesian plane. Now let's start for this. So remember again, we're supposed to find this change, which will be given by d squared z dx dy, then into bracket squared, then this dz dx, then squared there, then d squared z dy squared. Remember, these are partial derivatives, all right? So we now get this term, we get this term, and we get this term. So we can start by dz dx, then square. So the function of x, we differentiate it twice. We had differentiated it once here, so we differentiate it again with respect to x. We shall get what? We shall get 6. Then d squared z dy squared, we take again the function of y that we had here, then differentiate it again with respect to y. So again you drop what? So in our case here, you shall drop the value. So we shall have negative of 6, then you have negative of 6y. Then the last one, we have d squared z, then you have dx dy. So we are saying you take the function that you differentiated with y, then differentiate with respect to x, and this we said again it is d dx of the function of y initially, so which was negative 3y squared plus 6x. So we now differentiate. This is the function you differentiate with respect to y, then you differentiate now with respect to what? With respect to x. So with respect to x, there's no x here, so with respect to x here, you get what? You get 6. All right. Now, so we solve it for the 2 points. So for 0, 0. So for point 0, 0, we shall have, so we have our value here. So we shall have, what is our value here? Our value is 6. So 6 squared minus d squared z dx gives us what? 6. So we have 6. Then d squared y, dz squared dz y, we shall have negative 6 of y. But now, since we have a y here, we just come in this point here, we check what is our value of y. Our value of y is what? Our value of y is 0. So 0 times negative 6 just gives you 0. Okay, so when you have a variable here, either x or y, you depending on the point that you have been given, just replace the points here and you replace them here and you get your values. So here in this case we shall have 36 minus 0, which gives you 36, and this value is greater than what? Greater than 0. Therefore the point 0, 0 is a saddle point, because when it is greater than 0, we have said it will be a saddle point. So therefore this one is a saddle point. So your point 0, 0 is a saddle point. Now let's check for the second point. So we shall have the change again. So our value is still 6 squared. Our value of x is still 6. Now let's come for 2. Now this one is 4. Let me just rewrite it here. So for 2, negative 2. Sorry for the mix up. So we have 2, negative 2 here. So now let's check our value. So replace your value of y here, because we have negative 2. So negative 2 times negative 6 gives you a 12. So this one will give you 12, which is positive. So therefore we shall have 36 minus 6 times 12, that probably gives you 72. And 36 minus 72 gives you negative of 36, which is less than 0. And we have said if your value is less than 0, we have two possibilities. It can either be a maximum or a minimum. It can either be 2. So if it can be a maximum or a minimum. But now therefore you come and check, but what is our d squared z dx squared? Is it greater than 0 or less than 0? So we come back here and check what is our value. Our value is 6 is equals to, so but this one is equals to 6, which is greater than 0. And if it is greater than 0, then we say this point is a minimum point. So therefore hence 2, negative 2 is a minimum point. So, and that is the way you solve your two values. So you'll get two stationary points, and their nature, we can see they are totally different. The first one is a saddle point, and the second one is a what? The second one is a minimum point. And that is it for stationary points. So any question that applies to partial differentiation, the procedure follows the same way. So again, remember to subscribe, share, and also do what? And also comment.